just going to fill these out of what we did the previous night. All right. All right, so here is our basic sine graph. Okay. Here's our basic sine graph, which, let me just tell you, those 5 points are your key points to remember. Okay. Those are the same trend over and over and over again. You're going to see a lot of repetition today in terms of the points, okay? So we'll end up sticking. So this is our parent function, which, remember, for absolute value, for quadratics, for square roots, for cubics, whatever we looked at, any graph we looked at over the course of this year, we always had some sort of parent function, even exponentials, okay? Even though those kind of change throughout, but you always had a parent function. When it changes is when we have transformations, okay? So hopefully you noticed that domain for sine and cosine functions are always going to be negative infinity to infinity because it's constant, okay? You also saw the range is from -1 to 1. That can change, okay? -1 to 1 is your minimum to your maximum, your bottom of your Ferris wheel to the top. It's the same thing. It's just oscillating in between those two values. It keeps happening, all right? So, a few words, okay? One full rotation we see is 2 pi, right? That word, what that means is the period, okay? The amount of time that it takes to complete one full cycle, which in this graph is 2 pi, before the pattern repeats itself, okay? So the period of our parent function, a lot of p's there, is 2 pi, okay? The period of our parent function is 2 pi, means it takes 2 pi units to complete one full cycle, okay? So, another term that we should remember is called the midline, okay? The midline is the center of the graph, which can change. So, your unit circle from 0 to 180, that is your midline, okay? Thinking of the unit circle. On the coordinate plane, it's y equals 0. It's the middle of your graph, okay? Now, who could tell me what is the distance from the midline to your maximum value? Yeah, okay. 1. So the distance from here to here is 1. What is the distance from your midline to your minimum? 1. It should be the same because this is called the amplitude, okay? That is called the amplitude, all right? So the amplitude of the parent function is 1. And one thing with the amplitude, it's always positive, okay? The amplitude is always positive, right? So we're going to be working with transformations again, okay? Some values that we're going to see are A, B, C, and D. We use it very simple, A, B, C, and D. However, A, C, and D are very similar to A, H, and K. A, C, and D are very similar to A, H, and K, okay? Just their terms are different, all right? The first thing we're going to look at is the amplitude, okay? So what we're going to do first is we're going to, in this first graph our parent function, okay? Sine of x, so f of x. So we know for our parent function, we have it set up as is. Parent function, the midline is 0. For sine graph, where do I start? At 0, good. Then pi over 2, where would I go? 1, good. Then, good, good, perfect. Okay, so this red graph is my parent function. Okay, now, looking at g of x, what is my a value? What is my amplitude? What would it be? Yep, of this new function. 1/3. So your amplitude is now 1/3. Is my midline still the same? Do I have a plus or minus d, like outside here? No. So my midline is still 0. Okay, so midline is still y equals 0. However, my amplitude is 1/3. So from the midline, we count to our amplitude, which is 1/3, above and below. So my graph has to fall between those two bookends. Okay, so the distance from the midline to the max is your amplitude. All right, where do we start this graph? No, careful. Still at 0. Then pi over 2, where will I be? 1/3 pi. Okay, 3 pi over 2. And then 2 pi. So, again, same trend. However, what did we have? Yeah, Brad. Small amplitude, which is a compression. It's a compression. The vertical height compressed. Okay, so that 1/3 means it's a compression. Okay, the amplitude is smaller. The height. Think of Ferris wheels you've been on. Not all of them have the same height from the center. That could change. Okay, so if we look at number 2, okay, we're not going to graph our parent function here, but we have -5 sine of x. Okay, what is my midline? 0, good. My midline is 0. Right. Okay, what is my amplitude? 5. Excellent for saying positive. Your amplitude is always positive. So, from 0, or midline, we're going to count 5 above and 5 below. However, what else is happening here? A reflection as well. Okay, so sine functions, where do we start? 0. Okay, now pi over 2, where will I go? Excellent, because of reflection. Then pi. Where am I at pi? 0, good. 3 pi over 2, and then 2 pi. Good. Excellent. Good job. Try number 3. So, for number 3, what is my midline? 0, right? Our midline is still 0. Good. What is my amplitude now? John? 2. So, knowing that, what would be the highest y value? 2. The lowest? -2. Excellent. So, where am I starting? 0, pi over 2, where will I go? Pi, 3 pi over 2, and 2 pi. Excellent. Good job. Okay, so those first 3 graphs just focused on the amplitude. Okay, very straightforward. It goes through the stretch or the compression or even reflection. Okay, so now we're going to look at moving our graph up or down. Okay, which means your midline is changing. So the center of the graph is moving either up or down. So if we look at number 1, What is my new midline? 3, okay? This is my midline of 3. Okay, so that's what I'm going to graph first. Okay, what is my amplitude? Andrew? Our amplitude is 1. So, from my midline, and my amplitude is 1, 3 plus 1 is what? 4. That's going to be the highest point I reach. 3 minus 1? 2. So that's the lowest point. Okay, does everyone see that? The distance from the midline to the max should be your amplitude. So you're just adding 1, and then the midline to your minimum, you're subtracting. Okay, where do I start? At 0. Okay. We start at 0. 0 what though? 0, 3, because we moved up 3, right? Then pi over 2 will be where? 4 pi 3. 3 pi over 2. And then 2 pi. Okay. I hear a lot of you guys say 0. Just be careful that it's your midline. Okay? So, same trend though. Midline, max, midline, min, midline. Okay? So 0, pi, and 2 pi are your anchors on that midline. Okay? Your midline was 0, but now everything shifted up 3 units. Okay? So when you're coming back, a lot of you said 0, make sure we're saying the new midline. Okay? Does that make sense? Yes, no? Yes, no? Okay, let's try a few more. For number 2, what is our new midline? -1. Okay, so let's graph that first. Here's -1. Okay, what is my amplitude? John? 1. That hasn't changed yet. Okay, so if my amplitude is 1 and my midline is -1, what is the highest point? 0. What is the lowest point? -2. Good. Does everyone see that before I move on? How are we getting that? Okay, yeah, Brad. Yeah, go ahead. Okay, so where am I starting? What y value am I starting at? 0, -1. Excellent. Okay, then pi over 2, where will I go? 0, good. Pi, -1, good. 3 pi over 2, and then 2 pi. Good. Excellent. Okay. All right, are we okay? Okay. We are going to look at, we're going to skip this next one, and look at tying those both together. Okay. Does anyone need me to go back, or are we okay? All right. We're going to tie both of these things together. Okay. Our amplitude and our midline. What you first want to do is graph your midline. So for number 1, what is your midline? Sam? 1. Our midline is y equals 1. Okay. What is our amplitude? What's our amplitude? 2. Good, there we go. This is our amplitude. Oops. 2. Okay. So that means from our midline, we're counting 2 above. So what's my highest value? 3. Good. What's my lowest? -1. Okay, everyone see that? All right. Where am I starting? Yeah. 0, 1. Good. Then pi over 2, where will I be? 3. Excellent. Pi. 1. Good. 3 pi over 2. -1. And then 2 pi. Okay. Does everyone see? Just want to make sure. Are we okay? Okay. Now for number 2, where is my midline? For number 2, yellow. -2. Okay. What is my amplitude? John? 1, but what else is happening? Excellent. My amplitude is 1, but there's a reflection. So, what is the highest y value I will reach? What is it? -1. What is the lowest? -3. Okay. Where am I starting? 0, -2. Okay. Now pi over 2, where will I go? -3. And then where? Excellent. And then where? Good. Then? Excellent. Good job. Okay. Try number 3. All right. Try number 3. What is my midline? 4? 3. Good. Okay, so this is 3. What is my amplitude? 1/2. Good. So what would be the highest y value? 3.5. What would be the lowest? Good. Okay, where am I starting? 0, 3. And then where? 3.5. Then where? Good. Then. Good. Okay. So what we just did is we took care of the amplitude and the midline. Okay. Again, transformations mean the same thing, right? Moving up or stretch or compress or even reflect. Okay. With the sine functions, it follows the same trend. Cosine we will see a little later. Okay. Cosine follows the same trend as well, just the graph looks a little bit different. When we get back from lunch, we're going to focus on when the cycle changes. Okay. When the full cycle changes. All right. Awesome job, you guys. Head to lunch. We talked about, and this is pretty much the last thing we will get to, okay, just to keep in line with everybody else. All right, so we talked about before lunch how the cycle can change, okay? So typically, on our parent function graphs, one complete rotation is 2 pi units or 360 degrees, okay? But that could change, okay? When we have a number in front of x, so we're going to start with number 3, because that's a lot easier than these. So when we have a number in front of x, that means our period is changing, okay? So in order to find the new period, we do 2 pi divided by this b value. So that's 2 pi divided by 2, which is pi. So one complete rotation is going to happen in pi units, okay? One complete rotation is going to happen in pi units, which means we're used to 2 pi, so it's now cut in what? Half, right? One full rotation has to happen in half the time. So if you noticed on all these other graphs, the increments are the same all throughout. What are these going up by? 1/2 pi, right? They're increasing by also 90 degrees. It's consistent. So in order to be consistent, we know there are going to be 4 increments here, okay? How those are determined is we take our new period, which is pi, and divide by 4, always. That is always going to be the case. So our first tick mark there is pi over 4. What would be the next one? Brian? Excellent. Pi over 2. Then what would be next? 3 pi over 4. Good. And then finally with pi. All right, does everyone see that? So no matter what, if you have a new period, you're dividing it by 4, always. Okay? So what is our amplitude here? 3. What is our midline? 0. Good. Where am I starting the sine graph? 0. Good. Now pi over 4, where will I go? 3. Good. Then pi over 2? 0. 3 pi over 4? -3, right? And then pi? It's back at 0. So, to you guys, it might look exactly the same, right, as what we did above. But when you get to a normal scale, okay, where you're not writing it in, you're going to see the difference. So if I go back up to this one just to show you, if it was cut in half the time, that's what it would look like, okay? All right, so it's cut in half, all right, to complete one rotation. So now, if we look at number 2, and then we'll eventually get to number 1. For number 2, yeah, go ahead, John. Okay, so this represents, if we go back to our transformation equation, okay, A is our amplitude, B, the numerical value, is going to change the period, okay? C is our left-to-right shift, and D is our midline, or up and down, okay? So the numerical value, or sometimes it could be radians too. You could have radians there as well when you're dealing with some whole numbers, okay? So that number in front, typically it's 1 if we don't see anything. If we see another number, it changes our period, okay? All right, so looking at number 2, we have 2 pi. Our B value is 1/3. What is our new period here? Yeah, it would be 6 pi. We multiply top and bottom by 3 to get 6 pi, okay? So we know we are ending at 6 pi units, okay? So again, to be consistent, we're going to have the same intervals throughout, okay? So we have to take 6 pi divided by 4, so we could reduce here, okay? So we're going to increase each time by 3 pi over 2, okay? So we're adding 3/2 every single time, okay? So what would be my next increment here? 3 pi, good. Then what's next? Excellent, good. What is my amplitude for this one? 1. What's my midline? Good. Where do I start? And then where? And then? Good. And then? Good. Excellent. Okay? So no matter what, you always divide by 4. And one thing to keep in mind, it's a smooth curve, you guys. Okay? There shouldn't be any points. It's a smooth curve. All right? Try number 1 on your own. All right. What is the new period for sine 3x? What do we have? Anybody? Yeah, Bri. Okay. 2 pi over 3 is correct. Okay. 2 pi over 3. All right. Anyone figure out the scale? Sam? Pi over 6. Okay, so we take 2 pi over 3, divide by 4, right? So to get rid of that 4, you multiply top and bottom by the reciprocal, okay? So we end up with 2 pi over 12, which is pi over 6, okay? So after pi over 6, what came next? John? Pi over 3, and then? Excellent, okay? What is my midline? 0, amplitude? Good. And where do I start? 0, and then, and then, and then, oops, God bless you, and then 0. Good. Okay, so it follows the same trend over and over and over again. Okay, so I want you guys to try only 2 of these. Okay, I want you to try, let's do 1 and 3. Okay, I want you to try those on your own. It's with your amplitude changing and a period change. Okay, 1 and 3. You may work with somebody, if you like, to go through 1 and 3. Only 1 and 3. And then you'll just get into practice. All right, for number 1, okay, for number 1, what was the period? Pi, good, because we had 2 pi over 2, which is pi. What is the increments? Pi over 4, good. So we have pi over 4, pi over 2, thank you. And pi, what's our amplitude? 1, always positive, but what's the deal with that? It's reflected, so we're still starting where? Okay, then where? Then where? Then where? Perfect, good. Okay. Oops. Awesome, how many of you did get that? Perfect, okay. Now number 3. What's the period? Pi over 2. It's 2 pi over 4, which is pi over 2. Okay. What are the increments? Pi over 8. Okay. Because you take pi over 2, divide by 4, which is multiplying top and bottom by 1/4. That's how we get the pi over 8. So after pi over 8, what comes next? Pi over 4, excellent. And then what? Thank you. Okay. What is our amplitude? 1/2. So up 1/2. Where do I start? Good. And then where? Then. Good. Oops. 0. Okay, awesome. Good job. Any questions? Andrew?
Do you have to simplify for this period? Or do we just take that?
Take 2 pi over 4 and then divide by 4. You can, just make sure you simplify in the end. Okay? All right. All right. Awesome job, you guys. We are not going to get into cosine